Okay, thank you very much. Let's start. So I'm going to occupy the whole 40 minutes, so prepare yourself. So today we're talking about combining mobile CICD tools and cloud app protection tools. I will describe what those are. And the first thing I want to say is that, despite the talk being about mobile development, the concepts used here will be applicable for other CI/CD tools and so on. Okay, I bet you feel all a little bit sleepy. So let's have a little exercise before we start. So here's my hand, right one. I'm going to place it down below, and I'm going to raise it up. And during this raise, you will clap louder and louder and louder. Okay? Everybody understood what we're going to do? Okay, let's go. Yeah! Great. It will keep you energized a little bit. And the clapping is all about, we came here learning. We're getting to know new things, so that's great. Okay, let's go. I want to start with a story. So back in 2019, a third of all the Chinese population contacts and names were leaked and ended up in the black market. How it happened? Well, supply chain attack. Basically, the library for in-app purchases and analytics called SW Analytics was altered to gather the contacts. And this framework was used by 12 applications. And it was downloaded by more than 100 million users. So basically, the framework detected that the application started, then started to gather in the contacts, and then sent them to the remote server. And you can imagine the impact of that amount of social engineering, spam calls, scam calls to those people. So yeah, we need to be very careful. We need to treat our products very carefully and avoid such things. So yeah, my name is Vladimir Ivanov. I'm the author of the Architecture Weekly newsletter, and there's an URL down below. You will have the slides, so all the links will be there. I have more than 10 years of mobile development, and actually some of those years dedicated to solution architecture in different companies, EPAM Systems, Tinkoff Bank, and now Bolt. So now I'm leading the billing unit in commerce. Actually, this talk is not based on the experience at Bolt, but based on the article I wrote a couple of months ago and all my previous mobile experience prior to Bolt. Okay, so let's go. Why do we use mobile CI/CD in the first place? Well, actually, we as developers, we require a lot of things for us, so to do our job. So when we write code, we want to create pull requests and merge it eventually in the main branch. Then we want to deploy our product, right? And from the perspective of a mobile application, we want to build a mobile application, put it to the Google Play or App Store. We want to do the proper releases. We want to run our tests. We want to receive the test reports. We want to analyze what happened with those tests, which failed, which not, and what we want to improve. We want to receive the notifications about our build being successful or failed. We want to know that a particular task that we were working on completed successfully, right? So we want this issue track integration. For example, if you're using Jira, who uses Jira? Come on, okay, most of us. So when we complete a particular task and we create a pull request, a build for this task, we want to see this integration that, okay, release was successful, we can close the task, and everything is fine. So basically, we have very high level of expectations of our tools, right? DevOps tools, how do we like to call it? And aside from that, if we see a bigger picture, we want to work in parallel. So a typical teams are like 7 engineers, right? And maybe you can have products that have multiple teams. For example, I used to work for a mobile application that had like 20 mobile teams, and we want to work in parallel on this application. We want to work very fast, and we want to limit our time to market, right? So everybody is talking about like how DevOps enables short time to market, and this is one of the core requirements that we show to our CICD tool. And despite of going really fast and being able to deploy the application fast, we don't want to trade quality for that, right? So we want to have a very high bar of the quality of our application, because like if the application is shit, the users are not coming back. So we wanted to have real quality. And we do a lot to do that, right? So we write unit tests, we run them on the CICD, we want end-to-end tests, we want a good test report, we want a link between the failed test and the commit, and so on and so on. So we need appropriate tools for that, right? And then we go to having cloud CICDs. Why mobile developers go to cloud CICD solutions and not build anything based on the Jenkins? Well, because mobile development is a little bit tricky, right? So first thing, you need a dedicated hardware. Of course, you can build an Android application based on any Linux machine. However, building an iOS one require Apple hardware, Apple operating system, and you need like Mac Mini or MacBook for that, or anything like that. And you need to purchase this. This is CapEx, which is not great. Then we want the CICD to be secure and store our certificates, our passwords, and so on and so on. Because mobile applications, we need to sign them in order to be able to upload to Google Play or App Store. And those secrets are critical, right? Because if somebody has those secrets, they can replace the application that you're trying to publish, and the application is a very valuable asset. Then we want to be able to run tests, and if you have a single Jenkins installation, you need to do something about it. You need to connect the device to run the tests. You need some test harnesses for that. So this requires effort. We want to deploy to stores, and this requires, again, some integration from our Jenkins installation to App Store, Google Play, or other third-party stores. We want to receive notifications about the builds, and in general, we want a convenience from our CI/CD tools, because developers really want to focus on bringing features to their end users and not to think about how their Gradle build works. Okay, so this is where cloud CI/CD solutions come to our world, because they provide this convenience, right? So they say, hey, we have already the templates for Android application, for iOS application, for React Native application, for anything you want. We have all these testing capabilities in place. We have all the hardware managed for you. And every half a year or a year, a new Xcode version comes out, and we need to update our Mac machines to use this, and cloud solutions do that for us. So we just pay a relatively small fee for that and have it all out of the box. So yeah, cloud CI/CDs are convenient. And despite the convenience, we have bigger expectations from them. So one of the first expectations from a cloud CI/CD solution, or any CI/CD solution actually, is the reproducibility. And what I mean by that is that if you have a single revision stored in your Git repository, you expect the same build being produced no matter how many times you run this build, right? So you want to be sure that the APK you built with this particular version, it will be the same if you run the pipeline again. Also, you want this CI/CD solution to be secure and protect both your secrets and your application, and not expose your source code or parts of your application or anything like that to external parties. And of course, we want it to be really available. So what's good about local installation, that you can manage it and be sure that it's available once it is required. For the cloud CI/CD, you don't manage that anymore. You rely on your partner. but you expect a certain level of availability because you want to deploy at like any time because time zones, and development life cycles. So you want your like cloud CI/CD solution to be really highly available and be available at any moment that you need it to be, and actually many more. And this is the reason why it is very important to have a very good reputation among the clients, right? So cloud CI/CD vendors do a lot to build up this reputation and do not break the trust of their clients, because like otherwise they will just straight up losing money. Okay, so if we speak about the security, right, because the talk is about like safely combining one tool with another tool. So speaking about the cloud CI/CD providers, they do a lot. They put a lot of effort into their platform so it is secure. So first of all, they use virtualization and containerization. So basically they want to separate an application of one client from an application from another client so they don't interfere, or that nobody can tamper with a particular application, or to minimize the time that the source code of the application lives on the cloud CI/CD environment, right? Because this is available asset, and like the less the build time, the less the presence of this code, the less the probability something will happen to that. Then we have, like, when we build the application, it is like APK file or an IPA file. And typically cloud CI/CD tools, especially for mobile, store those in S3 buckets. And S3 buckets are tricky. People tend to forget about access list and forget about the security of those in the first place. And you can like search for or open S3 buckets out there, and this is like a primary reason for data leakage. So cloud CI/CD providers, they pay a lot of attention to the security of those buckets, apply proper access list, proper write management, and so on. Of course, they also apply these airbag models, and they don't allow like everybody the admin rights, so they allocate the rights to appropriate group of people, like admin rights to only to a couple of people, and rights permissions to developers, read-only permissions to testers, and so on and so on. They also put a lot of network guards, came up with virtual private clouds, and many, many more that were covered by Miguel a couple of hours before. Okay, so what I'm trying to tell here is that cloud CI/CD providers put a lot of effort into the security of their solution, and they're able to do that because they control their environment. Okay, is it enough though? By the way, thanks to DALL-E for generating this image, so really appropriate. Okay, actually not. And this is where we start the talk about how our world changed from the perspective on how we consume the digital products, right? So 10 years ago, it was a desktop primarily. Right now, it's a mobile application. And for many, many, many services in the world, be it on online platforms or online bankings or games or whatever else, mobile application is the main or single product that the client communicates with. So this is a very valuable business asset. But there are a lot of threats to those assets out there. So, for example, you can face the reverse engineering or redistribution risk, or you can face the supply chain attacks that I covered with the story I began with, or you can face the IP loss. Let's take a little bit closer look. So, speaking about the reverse engineering, so imagine you have like an application that is able to report your taxes. And in the US, for example, there are whole businesses built on the premise that doing taxes is a complex topic, right? So they have desktop solutions and they have mobile applications that have this tax reporting logic on their side. And if you easily unveil this logic, like we can build a competitor for you, right? So you want to like avoid unveiling this logic for your competitors or for any malicious engines. Another thing coming from the reverse engineering threat is a redistributed application. So imagine the following scenario. We have an online bank, and then some malicious agent downloads the APK from Google Play, reverse it, patch it up, and push it to some third-party store or to some forum where people exchange the applications. And then when users start doing that, or when they were treated by the social engineering into downloading the new version of the app because of security reasons, right? So they start using this application, and suddenly their money goes to some obscure accounts, and they're not aware of it. So this is a very critical business risk to the online banking itself, right? So we need to protect from that. And like reveal secrets is a threat as well. Some of the mobile applications, they are built with the Xamarin technology, and this is a .NET-based technology. And it happens that combining the .NET technology with Microsoft Azure is super convenient. And there are mobile applications out there that use the authentication key of Azure right in the mobile applications. It is hard-coded there. And to reverse a Xamarin application, it takes like 2 steps, a 2-line script to reverse and find those secrets, and like your Azure access is compromised. So this is a real threat. Another threat is supply chain attacks, and here I want to tell another story. Back in 2015, there was a case with a library called Alarmifier. Raise your hand who knows what Alarmifier is. Okay, nobody knows. Actually, for iOS, when you do networking, you pick up some of the network libraries, and I have this Alarmifier is a very convenient library for that. And people are using this library to build up the network layer in their mobile applications. And like what comes to your mind security-wise when you hear networking? Anybody?
Packet capture.
Packet capture. Yes. What? Not really. What comes to my mind is like network sniffing and man-in-the-middle attacks, right? And the trick with this Alarmifier library was that accidentally it wasn't verifying the host of the certificate. So basically, if the application uses a buggy version of this library, you can speak to whatever man in the middle you want. And you can trick anybody with a mobile application connected to an unsecure Wi-Fi network to like speak to your bank server and not the original one. By the way, what Wi-Fi network your device is connected to? Tell me. Yes, is it secured? It's unsecure, so yeah, think about it. So yeah, basically, the example that I just showed is a case of a supply chain attack, right? So you rely on some dependency, and the vulnerability is being introduced to this dependency, and suddenly your application is at risk. So yeah, think about it. Okay, next one is IP protection, and here we need to talk about all those valuable things that you put into your application. So, for example, it may be art, or maybe some other assets, or maybe even machine learning models, which are very valuable. So you spend a lot of time of your machine learning engineers to build up a model, and if you don't protect it and include it in the application, then like it leaks to your competitors, and your business is at risk again. So yeah, this is like the third major risk that I want to talk about. Okay, the question right now is what do we do about it? How do we fight those threats if our CICD tool cannot help us with those threats? The answer to that is that we need the application integrity in the first place. So we need to make sure that it is very hard to tamper with our application, so that we include a lot of checks that our application is safe, that it can detect any attempts to tamper with it. For example, we use cryptographically ensured application integrity. So you're not only doing the CRC32 checksum, but you actually use HMAC algorithm to cryptographically check your application integrity. Or you do the application device assessment. So basically, once the application is on the device, so first of all, it checks its own integrity. Then it checks the device that it's not rooted, for example, or jailbroken, or there's no malware on the device. So it assesses the device security state, and so on. And we continue to monitor the state of the application from the server side. So we see if there's some malicious activity from the application and it behaves in a strange way, and so on and so on. So we really want to focus on the integrity of our application, as it is like the key aspect of mobile application security on the device. Okay. Another thing that we can do is the runtime memory protection and like anti-dynamic protection, because there are tools like Frida that allow you to modify the behavior of the application in the runtime. So yeah, we want to incorporate integrity to fight all of those threats. Okay, but now you can tell me, hey, my mobile team is like 3 engineers, and they're the whole time they spent on the features. We don't have a security professional in-house. What do we do? And then cloud app protection services come into picture, because they say, hey, we know the security much better than you. Just give us your application and we will ensure the integrity of your valuable application for you for a small fee. And of course, there are some examples of this. There are AirWatch, there are Mobile Iron, there are plenty of other services out there, and they're all cloud-based, right? So you just upload the application to them, download the application to yourself, upload to the App Store, and everything is happy. Well, yeah, maybe. Let's take a closer look. So how it happens? So you have your CICD pipeline, or maybe several pipelines in your CICD environment. And then you have this app protection tool to the side that you want to wrap or protect your application with. And you hand over your valuable application through some kind of a network to this app protection tool. And then download the wrapped application back. And once you have the protected application, then you're free to deploy it to Google Play, to App Store, or to some third-party application store. Okay. Any issues with that? Does anybody see any risks? Yeah, the application is unprotected. What's happened in the middle? Nobody knows. And actually, with this setup, we introduce a new set of threats, aside of those that we already identified. So first of all, traffic can be intercepted, right? Our application is not protected. There's no integrity in it. And we are free to reverse engineer it, or to modify it, or do whatever we want. Maybe there's malware on either side. Maybe on the side of this app protection tool. We don't know. Like, what happens there? What about supply chain attacks? Those vendors are subject to those attacks. And if they're like repackaging your application and introduce new libraries, those libraries can be subject to those supply chain attacks. And we know how drastically awful they can be. So, yeah, of course you can say, okay, let's apply additional protection layer. We can use VPN, for example. Or we introduce some encryption to hand over the unprotected application. But then the question is, like, how do you manage keys? Because encryption is really a simple thing. You just apply an encryption algorithm. But managing the keys, rotating them properly, making sure that they are not leaked, this is a hard part. Or like we can use the SSL pinning and ensure that our like HTTPS connection is protected against man-in-the-middle attacks. But this is again another level of effort. So so basically what I'm trying to say is that when you introduce a new party in your setup, like the whole new set of threats arises, and like supply chain attacks or malware. Or if we're speaking from the availability perspective, like imagine you have a really important release. Say tomorrow a new EU legislation comes into the force, and you want to make a new release with your new prepared application, and then hop, and this application protection service is unavailable. You try to reach out to the support, but they keep silence for 2 hours. And then once they are online, they're like, we don't know what happened. We don't know. And like, what do? You just publish the unprotected application? bad idea, right? So what I'm trying to say right now is that we're at a very high risk of combining the app protection tool and cloud CI/CD service, right? So the service can be unavailable, or it can be a threat to the malware, or there's a threat of a supply chain attacks, or whatever happens next. And when you have a cloud CI/CD solution as a separate entity that you control, then everything is fine because you can ensure the security of the environment. But if you combine two environments, like, nobody is responsible for making the whole thing secure. So this is a high risk. What do we do? Well, the recommended approach is the following. So if you treat your application as a valuable business asset, please make sure to apply all the protection tools while being inside the CI/CD environment. So basically, the recommendation is the following. Please try to build up your CI/CD pipeline as it's shown here. So basically, once you have the source code, check out it within your CI/CD environment, then apply your build tools, then run your tests with whatever tool you want. Here's the Caspresso, by the way. Then apply the security, the security scanning, the vulnerability checks, dynamic security testing, and so on and so on. And once you're sure that you're good with your application, please don't leave the CI/CD pipeline. Apply the app protection tool in the boundary of this CI/CD pipeline. And here's the DEX protector icon here. And only once you applied the protection, then you're okay to deploy it to Google Play, App Store, or any other environment. Okay, so one of the examples of the cloud CI/CD tools is a Bitrise. I used to work with them, so they're pretty convenient from my perspective. They have a list of verified steps that can use the app protection tools inside the CI/CD environment. So one example is a DEX protector, another one is the AppRay mobile security, and there's a list of other ones that you can apply. So not advocating for anyone, pick the one that you like the most, that you find convenient for your goals, but please do it inside your CI/CD environment. Okay, so please safe building, let your apps be really protected from the threats out there. Okay, so I have a technical blog where I write articles about software architecture, system design, mobile development, mobile security, and so on. So the address is here. My newsletter can be accessible from this website and from the Telegram channel. Link is here. I also have a YouTube channel that covers the system design, software architecture, and so on, and newsletter as well. And if you really like the talk and the content, you're free to support this work through Patreon. That's it. Thank you very much. Your questions?
Thank you. Very excellent talk. Please wave if you want to ask a question.
So we understand the idea why people are kind of like, as you at the beginning explained, why they are using like cloud things is probably it's also kind of like cheaper considering not needing to buy the things. And now you're saying that, okay, you still need to buy these things. So have you kind of like, what is the price difference of doing it on your own or renting cloud services? Or maybe actually the cloud services are kind of like boosting or telling that, oh, it would be so difficult to do it on your own. And actually it isn't. So is there a kind of like price incentive to not kind of do it on your own?
Okay. Let me provide an example for that. So while in EPAM systems, we used to run our own Jenkins for almost all the clients that we have there, and we had a lot of clients. And this Jenkins was supported by 3 engineers. So you can imagine the cost of this thing. However, despite being supported by a separate team, it was not very reliable, right? So there were always the problems. We need to update the hardware. Something was broken. We need to support our internal tooling for building up the CI/CD pipelines for new applications really fast, and so on and so on. So that came with a cost of lost opportunity, I would say. Okay. Then we switched to Bitrise, and first of all, it was very convenient. and we were able to scale like very fast. Every new client that we had with the mobile application, we could set up like all the mobile CD in a week of the time. So that was really convenient. How much did it cost us? Like 3 years ago, it was $9,000 US dollars per year. So this is much less than 3 engineers on the payroll. So, any other questions? No? You can find me later if you come up with any. So thank you very much.
Yes, let's have a big round of applause.